p42, which is a summary of matter classifications and means of separation. So I'm going to start here in this first box. This first box represents our most mixed up form of matter, which we would refer to as heterogeneous. So when we look at a heterogeneous sample of matter, it is always a type of mixture. And so it lacks any type of uniform ideas. There's a lack of uniform composition, lack of uniform structure. So heterogeneous, things like this, that if you have to stir it, if you have to shake it, if you can see layers, or you notice particles that are settling, these would be all big ideas letting you know it is a heterogeneous mixture. And many times there are visual differences. So there are visual differences when you're looking at a heterogeneous mixture. Heterogeneous mixtures, they can be put through a physical separation. So they can be put through a physical separation to separate out these components and to create a sample of matter that is more homogeneous. And so if our sample is more homogeneous in nature, the big thing is that there are no visual differences. Because there is a uniform particle distribution. So I'm going to write uniform distribution. So there's no more layers, there's no more settling, you don't need to stir or shake it. So typically, if you're looking at a sample and it looks pretty uniform, you can't spot any differences, it is homogeneous in nature. So if it's homogeneous in nature, our most complicated form of a homogeneous or a homogeneous sample of matter would be a homogeneous mixture. And for us, important words to associate with a homogeneous mixture. So in our chemistry class, if it's ever labeled with the phase of AQ, or we specifically refer to it as a solution, for us in chemistry class, that's buzzwords for a homogeneous mixture. A homogeneous mixture, like a heterogeneous mixture, we can use a physical separation process to separate the components from each other. Now, when we put a homogeneous mixture through a physical separation process, we end up separating the components into individual substances. And when we end up with an individual substance, each in their own container, that means that there is only one type of particle. In that new container. Before I go on, I want to add the separation processes here. So a heterogeneous mixture, to separate it and to create a more homogeneous sample, we would use techniques like filter, sort, maybe a magnet, depending on the nature of the items in there. We could decant or use that separatory funnel. So all of these techniques would work to change or to separate a heterogeneous mixture into samples that are more homogeneous in nature. Once we form the homogeneous mixture, we have to change the techniques. So techniques that will help us separate the components making up a homogeneous mixture into individual substances. This is where we would use the idea to evaporate or gently heat off the liquid portion and leaving a solid behind, a dissolved solid behind, so we can evaporate. This would be where we would distill two liquids based on a difference in their boiling points, or we could possibly use chromatography. So depending on the type of mixture and components we're trying to separate, that's where we carefully choose the technique. So now we are at the point of substances where our container contains only one type of particle. Our most complicated form of a substance is the compound. And if it's a compound, the key ideas that we should think about here is that we have different atoms in a fixed ratio. So we have a fixed ratio of different atoms as a short way of putting it. So examples of a compound like C6, H12O6, H2O, CO2 would be just some examples. There's many more chemical formulas of compounds that you know. So a compound, it can be separated into individual elements. And once when we hit the idea of it being an element, that means that it specifically goes from one type of particle, where now we have only one type of atom present in the chemical formula. So things like P4 for phosphorus, O2 for oxygen, Al for aluminum. In each of these formulas, there is only one elemental symbol present, even though the subscript may not be one. They each represent an individual element because each formula is only one type of atom. Now, in order to separate a compound into the individual elements that make it up, it is not a physical separation. This is where it requires a chemical reaction. And the most common one to go from straight chemical compound formula to each of the individual elements making it up would be a decomposition reaction. So a compound can be chemically broken down into the individual elements. Mixtures can be physically separate the components from each other. Once when we hit an element is the form of matter which is the simplest. We cannot separate it physically or chemically, so we cannot break down. That is as small as we can go physically and chemically in the lab.